Since its founding in 2008, Microsanj has striven to be a world leader in the development of advanced thermal imaging systems. In the next several minutes, I will provide you an overview of the current Microsanj thermal imaging product line, and with that, hopefully you will agree that we do have some of the best thermal imaging solutions to address your thermal imaging challenges. Our design focus is simple: develop and offer thermal imaging systems with the spatial, temporal, and thermal resolution required to meet the thermal analysis challenges presented by today's most advanced micro and optoelectronic devices. The thermoreflectance technique is a key thermal imaging approach embedded in all of our thermal imaging systems. This approach provides the spatial resolution necessary to address the requirements for analyzing devices with ever-decreasing feature sizes and supports fast transient response, an essential attribute with submicron features, since thermal events can occur more rapidly with these types of devices. Most of our systems also support infrared emission thermography to take advantage of the thermal sensitivity this imaging technique offers. This enables the detection of very low power hotspots or other circuit-induced thermal anomalies that may contribute to an early device failure. Microsanj thermal imaging systems can be broken down into three major categories, using transient response as the primary differentiator: 50 microseconds for the EZ-THERM series, 50 nanoseconds transient response for the NanoTHERM series, and sub-nanosecond or picosecond transient response for the PicoTHERM series. Other key differentiating attributes are highlighted here in red. Dual mode capability, thermoreflectance plus infrared emission, is supported in both the EZ-THERM series and the NanoTHERM series. Other performance specifications shown here will be discussed in more detail on slides that follow. All of our systems are managed by the embedded Microsanj developed SanjVIEW software. SanjVIEW is a software package for which considerable effort has been expended over the years to ensure an intuitive, user-friendly interface and system ease of use. The software comprises several modules to perform system management, image capture, and data analysis. Sanj Analyzer Plus is an add-on module to facilitate more advanced post-data analysis, enhanced report generation, and provides a simple interface to MATLAB. It also includes other proprietary algorithms to support other advanced system features. Many of our ongoing system feature enhancements are software-based, thus enabling easy upgrades for previously delivered systems. Once the imaging system is powered on and the sample placed on the thermal stage with an appropriate bias supply applied, most other additional system operations are controlled with intuitive screen displays similar to what you see here. When evaluating thermal imaging approaches to fit specific applications for thermal analysis, it's important to understand the features that distinguish our imaging solution from other thermal imaging approaches. Key distinguishing features are shown on this slide: a multi-mode head to support up to 3 simultaneous sensors, either thermoreflectance or infrared emission, with easy and simple transition from one sensor to another. IR plus TR functionality to capture the best features of both techniques in a single system. Auto illumination wavelength selection, transient cal, and hyperspectral imaging ensures optimal thermal mapping over the region of interest, which may include several different materials and several surface characteristic differences. Transient Cal enables thermal calibration for feature sizes below the diffraction limit. Auto positioning and autofocus is supported to compensate for sample movement during temperature cycling. This is an essential capability when investigating devices with submicron features. Now let's look at each of these systems in a bit more detail. The EZ-THERM Series is a compact, flexible, modular platform that can be cost-effectively configured to your specific thermal imaging application. It's an excellent choice for failure analysis or general engineering thermal analysis. We have provided a detailed description of the EZ-THERM Series in a separate video entitled EZ-THERM Product Announcement. In the rest of this video, we will describe the NanoTHERM Series with 50 nanosecond transient response, the NT220 for high-performance topside imaging, and the NT310 for through-the-substrate imaging to enable flip-tip thermal analysis, followed by the PicoTHERM Series with an ultra-fast sub-nanosecond transient response for research applications of materials, multi-layer structures, thin films, and so on. The NT220 is available in 3 configurations. Each configuration includes the LS300-4 Sanj source module with 4 auto-selectable wavelengths in the visible band, and the Sanj controller, which includes the embedded SanjVIEW software. An optional Sanj source module is available with up to 8 auto-selectable illumination wavelengths. The NT220 baseline configuration fits in a 12U high rack, which easily fits under a standard workbench, whereas the electronics for package 1 and package 2 are configured in a 22U rack. The NT220 package 1 adds a piezo calibration tool with a 40 by 40 millimeter stage working area and a 20 to 120 degree centigrade temperature range with 50 watt cooling capacity. Package 1 also includes a general purpose probe station. In package 2, we have a piezo calibration tool with a larger working stage, 125 millimeters by 125 millimeters, with a 20 to 150 degree temperature range and a 500 watt cooling capacity. The chiller fills the 4U slot at the bottom of the rack, but there still is a 4U slot for an optional accessory at the top. Package 2 also includes a more versatile gantry type probe station. Items included with each SanScope system, not shown here, are a 30-inch 4K display with a wireless keyboard and mouse, and the appropriate optical head with sensors and objectives. Here's an actual photo of an NT220C system, which was recently delivered to a customer. It's the most versatile of the Microsanj SanScope thermal imaging systems for topside thermal imaging. The NT220 platform can simultaneously support multiple sensors, and the modular architecture can be factory configured to meet specialized customer-specific thermal applications. In addition to a faster transient response, the 4-megapixel CMOS sensor supports a spectral response in the near UV band, making the NT220 series an excellent choice for the analysis of gallium nitride and other wide bandgap devices. There's been growing interest in these devices with submicron gate lengths for their power handling and frequency capability. The electronics rack for the package 2 option and the 22U high rack is shown in this photo. As described on the previous slide, the package 2 option includes a calibration tool with a large working area and a 500 watt cooling capacity and a gantry type probe station to provide a complete thermal imaging system with a transient resolution of 50 nanoseconds, submicron spatial resolution for the analysis and thermal analysis of the most advanced semiconductor and optical electronic devices that you may encounter. An IR sensor is available as an accessory to support dual-mode functionality for enhanced thermal sensitivity with macro-scale imaging, as described earlier. Now, as you can see here, adding an IR sensor is a very straightforward process. Simply screws into the optical head. The SanjScope NT310B thermal imager is configured with an indium gallium arsenide sensor for optimized spectral response in the near infrared range. With a 900 nanometer to 1700 nanometer spectral response, the NT310 series is ideally suited for backside or through the substrate thermal analysis, since silicon has a growing transparency to wavelengths greater than approximately 1000 nanometers. With increased interest in flip-chip mounting techniques for reduced parasitic effects in high-frequency applications, the NT310 is well positioned to meet the thermal imaging challenges necessary for these types of devices. As with the NT220 and the EZ-THERM series, an IR sensor is available as an accessory for the NT310 to support dual mode TR plus IR functionality to support enhanced thermal sensitivity with macro-scale imaging. SanjScope PT410A is the most advanced lock-in thermal imaging system in the Microsanj product line for transient analysis. Configured with a picosecond pulsed diode laser illumination source, the system is well suited to the scientific studies of submicron heat transport in devices. With transient full-field thermal imaging for topside imaging down to 800 picoseconds, the PT410 enables the study of heat propagation inside devices or multi-layers with hundreds of nanometers feature sizes or layer thicknesses. It can be used to extract interface thermal resistances inside a device, as well as non-Fourier heat transport due to quasi-ballistic or hydrodynamic phonon propagation. The electron multiplying CCD sensor covers a wide spectral range, adding to this system's utility in addressing a wide range of thermal imaging requirements and applications. While optimized for the visible band, the spectral response is sufficient to support basic backside imaging at 1060 nanometers. Over the years, we have acquired a diverse range of university and commercial customers worldwide that have used our equipment or our testing services to address their thermal imaging requirements for a wide range of applications. Some representative applications are 5G communications, artificial intelligence, automotive electronics, military radar systems, and basic research in nanoscale devices. Many of these applications require higher powers, higher frequencies, faster switching speeds, etc. Requirements typically resulting in smaller device features and more complex structures, which in turn lead to higher and higher power densities and thermal analysis challenges to ensure high reliability. We are pleased that our system solutions and our consulting and testing services have been able to play a key role in enabling these companies and universities to better understand and address these thermal challenges. We are certain that we can address your thermal challenges as well. Thank you for your interest in our thermal imaging products, and for more information, contact us directly at the addresses shown here, or contact a Microsanj representative in your geographic area. Thank you for your attention. We are looking forward to hearing from you soon.